All right, guys. I hope that you guys are happy. I hope that you guys are looking forward to it. I know that we are pretty tired, but I think we can survive. That's fine, miss. You're good. So let's go ahead and do this. And don't worry, we're gonna go as slow as I can, and I'm gonna explain as much detail as I can. And anytime you get confused, please let me know, and I will 100% stop and go from there. All right. So the whole point of today is to go from a sum. This is a sum to a product. That's all we're doing, guys. So we're going from a sum to a product. So how do we go from a sum to a product? So let me tell you first the preferred method that I would like for you to do it. And I don't know, if you show this to other math teachers, they might say, why are you doing all that work? Why don't you just use a formula? And to that, you just tell them like, well, because this is, Chavez wants us to know more than just a formula. But I will show you the formula, guys, I will. So here's how I would do it. I know that this is cosine of something plus cosine of something. And I know the composite argument properties. I know that this is cosine, and Chavez, you're going too fast. I don't even know what you're talking about. I know that I know this. I know what cosine of A plus B is. It's cosine A, cosine B, minus sine A, sine B. I know that, 100%. And we know this. We know cosine A minus B. We know that that is cosine A, cosine B, plus sine A, sine B. I can trick this equation and I can say, well, that 12 theta is nothing more than A plus B. And that 10 theta is nothing more than A minus B. And I can figure out what the A is and what the B is. And I can just add them up because there's a plus in the middle and see what type of product I get. Chavez, you're confused me. Okay, here's what I'm trying to say, guys. A plus B equals 12. Yes, ma'am.
Okay. If cosine 12 theta is A plus B, then why is cosine 10 theta A minus B?
Oh, I'm just trying to trick it. I'm trying to figure out two numbers that when I add them, give me 12 theta. And I'm trying to figure out two numbers that when I subtract them, give me 10 theta. I'm trying to do this. I'm trying to do cosine. Yeah, kind of like factoring. I'm trying to do this. See? I'm trying to do that. And then equals, and then I write what this is, and then I write what that is. And then when I add them together, something combines and something that does not combine. So that's what I'm trying to do. Let me write it better, guys. Let me write it better. And I know right now you're looking at the big picture and you're like, I am so lost and I have no idea what's going on. And right now that's an okay feeling to have because I haven't done anything. So what I'm trying to say is what two numbers that when I add them will give me 12, but those same two numbers, when I subtract them, will give me 10. Well, let's see. If I add these guys, the b's cancel out. 2a equals 22 theta. Divide by 2, and I get 11 theta. So that means b must be just 1 theta. Is this true? 11 plus 1 is 12? Yes. 11 minus 1, is that 10? Yes. So here's what I'm doing, guys. Here's cosine 12 theta. Do you guys agree 11 theta plus theta is 12 theta? And I'm going to write the composite argument property for cosine of 11 theta plus theta. Cosine 11 theta, cosine theta, minus sine 11 theta, sine theta. All right, check it out. Look at this. In the bottom here, I'm going to write cosine 10 theta. So I'm going to write cosine 11 theta minus theta. Does everyone agree that 11 theta minus theta is 10 theta? Yes, awesome. So check it out. I'm just going to expand it. Cosine 11 theta, cosine theta, plus sine 11 theta, sine theta. And I'm going to add them. I'm going to put a line, just like when you were in elementary, and you had two expressions, and I'm going to add them. So check it out. This is what I'm really doing. This here in green is this in green. And I am adding plus. That's a plus symbol. So that means I'm adding this expression, the top minus the bottom. When you add, look, these have opposite signs. These are going to zero out. And I'm going to have 2 of these. That is 2 cosine 11 theta cosine theta. And don't worry, I'm going to do a whole bunch of these. And if you don't like this, relax. I'm going to give you the formula in a little bit. Cosine 12 theta plus cosine 10 theta equals that. And there it is. That's what I wanted, guys. This is a product. How do we feel? I think this is pretty cool, but I don't know. Oh, Ms. Riley, that's a cool background. Where did you, okay, I know where you found it. Well, I was gonna ask where did you find it? It's all over the place. Okay. What do you guys think of this? Does it kind of make sense? Okay.
Will it always be a plus b, a minus b?
I always like to write the larger number as a plus b. Yes. If it would have said cosine 10 theta plus cosine 12 theta, I would have written the 10 theta as a minus b, because whenever you subtract, you want to get the smaller one. Does that make sense? Good question, miss. All right. So look at this, guys. And don't worry, we're going to go backwards now. But I'm going to see if I can do the same thing again. It says, all right, what if we want to turn a product into a sum? I can do the same thing again. You see how I have 2 sine 13 cosine 48? And I kind of wanted to make that 48 an a, but I'm not going to, because I don't want to confuse anyone. So, and I'm going to write the composite argument properties here on the side, guys. Look, which wave does has sine cosine in the composite argument property? Sine or cosine? Do you guys, maybe we don't understand the question, right?
Can you repeat it?
Yeah. What composite argument property, sine or cosine, has sine cosine as a product like that? Do we understand what that means? No, maybe.
Sine?
Yeah, sine. So here's what I was trying to say, guys. Notice that sine a plus b, this is called an argument, by the way. So the composite argument property for sine, look, it toggles sine, cosine, plus cosine, sine. So I want you to recognize they're the sine, cosine. So immediately I know that I'm doing sine. I don't know which one. Like, I don't know if I'm adding or subtracting, but I know that I'm doing sine a plus b, and I know that I'm doing sine a minus b. And I know that a is 13 and b is 48. So this is what I'm going to be doing. And I'm going to figure out what am I doing, if I'm adding the left-hand side or if I'm subtracting the left-hand side. Chavez, I'm totally lost. Okay. Do we agree that the 13 is an A and the 48 is a B? Okay, here's all you're doing. Here's all you're doing, guys. Sine, 13 degrees plus 48 degrees. That 13 is like an A, the 48 is like a B, and you're just going to expand it. Sine 13 cosine 48 plus cosine 13 sine 48. So do that. In the bottom here, I'm going to write the composite argument property for sine 13 minus 48. Why am I doing that? Because they want me to go backwards. They want me to go from a product, this is a product, to a sum. So I'm going backwards. So that's what they want on this one. See, product to a sum or difference. So I'm going to write sine 13 cosine 48 minus cosine 13 sine 48. I do a line like so, and catch up, and I'll go real slow right now. That wasn't a fart, guys. I opened up a Dr. Pepper. Okay. Here we go. I'm going to go slow. There's only one way to get 2 sine 13 cosine 48. How's the only way? Here it is. There's a sine 13 cosine 48. The only way to get 2 of them is if I what? Add or subtract?
Add.
Add. Put a plus symbol here. It's only by adding. If I add, these 2 dudes on the right-hand side are going to cancel out because they have opposite signs. And these two dudes, the sine 13, cosine 48, they're going to add up to sine 13, cosine 48. So what did you do? Well, in reality, what you did is this here on the left-hand side in blue. What you did is sine of 13 degrees plus 48 plus sine of 13 degrees minus 48. That's what you really did. So catch up to there, guys, and then we'll chat some more. And yes, there is a formula, guys, and I'll show you the formula. All right. Let's add them up. 13 plus 48, I don't know, 48, 58 plus 9, 61, 61 degrees. Plus 13 minus 48, that's a negative number. Sine of 48, 38, 35. Negative 35 degrees. It does. This is actually correct. You can actually leave it alone right here. But this tells me of functions with positive arguments. The word argument means inside the parenthesis. That's an argument. And it works. It always means argument, guys. So if you say ln of x, the argument in ln is the x there. I don't know if you knew that. I hope you did. But if you didn't, no big deal. So sine is an odd function. Odd function. So your final solution, sine of 61 degrees minus sine of 35 degrees. Now, do you guys want to see me use a formula? No? Yes? Okay. I'll wait. Catch up to here. All right, guys. So here's your formula. So let's say, man, I don't want to teach you guys. I don't want to teach you guys how to cheat. Okay, I'm gonna go ahead and do it. I don't agree to it, but let's say I just want to use the formula. Chavez, I just want formulas. Okay, here are all the formulas right here, all of them. If you just want to use a formula, here's how you do it. Just listen, don't write anything down. You just look at it and you're like, okay, I have 2 sine 13 cosine 48. I would probably rewrite this to help you out. I would write it as 2 cosine 48 sine 13. It's the same. It's the same. It doesn't matter how you switch it. And then I would probably do this, guys. I would probably go to my formulas and I'm going to look for that. So look for 2 cosine. Did I say 2 cosine sine? Yeah, I did. 2 cosine sine. So I'm going to come over here and I look for 2 cosine sine. On the bottom ones. Right there. And it tells me what to do. So look, I'm going to write it right here. Don't write anything down, guys. Just listen. So what did I have? 2 cosine 48 sine, was it 13? I already forgot it, guys.
Yeah, it was.
Okay. So this is what it says. So just listen right now. You don't have to write anything down. So using my formulas here, look, it tells me it's just sine x minus sine y. And it tells me what does it tell me to do? It tells me to that is half of x plus y, and that is half of x minus y. So we have to figure out what x minus y is. So let's see. How will we do that? Maybe this is not the best way. This looks kind of complicated to me. Times 2, x plus y equals 48, 50, 96, and then x minus y equals 26. I guess you can figure it out real quick. 2x equals 96 plus 26, 96, and 30, 106, 168, 126, 22, divide by 2, x equals 122 divided by 2, 61. Is x equals 61 in ours? Yes. And then you do the same thing for the y, and you'll get our y value of, I'm just going to cheat and go right into 35. Y of 35 degrees. And just don't write any of this down, just listen. And just use the formula, and you can just go sine of 61 minus sine of 35. I don't know if that was easier, guys. This is the first time I've done it. So if you saw me and you're like, oh man, that doesn't look, I don't know if that's easier. I don't necessarily think that's easier. Did you guys think that was easier? Nah.
I think the way we did it the first time was easier, just by doing sine A plus B plus sine A minus B.
You know why you think it's easier? Which I think it is. I agree with you. Because we already have a lot of experience with it. Isn't that cool? Oh, you guys don't think that's cool? Guys, the more experience you have, the easier it gets. Oh, now everything's all being messed up here.
I also think it's kind of easier, but I think it's also like nice to have the formulas because I like to know like be able to check it or like have like something to go by.
I agree, miss. I agree with you 100%. I just like to feel like I know what I'm doing. Don't you guys like to feel that? Like, oh, I know what I'm doing. All right, here we go, guys. And don't worry, I'm going to go slow. It says transform cosine 7 theta minus cosine 3 theta into a product of functions with positive arguments. So here we go. I'm going to go slow. I know that A plus B better give me 7 theta. I know that A minus B gives me 3 theta. This is a system. I'm just adding, guys. I'm just adding. 7 plus 3, that is 10. The B's cancel out, and you have 2A. 2A equals 10 theta. So that means A equals 5 theta. That number 5 is the score that we want you to get on your AP exams. Okay. Sorry, guys. I had to throw that in there. So now B. So if A is 5 theta, B has to be 2 theta because 5 theta plus 2 theta is 7, and 5 minus 2 is 3. So here it is. I'm just doing the logic that we already know. So Ms. Cruz is really good at this. 5 theta plus 2 theta. There it is. Ms. Cruz, you want to help us out and expand this one?
Cosine 5 theta. Now I'm nervous.
Oh, keep going, miss. You were doing good. Cosine 5 theta, cosine 2 theta, minus
sine 5 theta, sine 2 theta.
Good job. You got it, miss. Cosine 5 theta minus 2 theta is the exact same thing, except you change the minus to a plus. And then I do a line. I do. And what am I doing? I'll wait for you guys to catch up because I can see a lot of you guys writing. Let me drink some water now. Thank you guys for being awesome, for giving me the energy to continue this math math stuff. Okay, check it out. Am I adding these or am I subtracting these? What am I doing, guys? Adding or subtracting? Subtracting. So I'm gonna put this in giant parentheses. If it's a positive, put a minus. So here it is, now it's a minus. And so that plus turns into a minus. So this is my new sign, the minus sign. So now these go away. And these add up, these in green. So what am I trying to say? I'm trying to say that cosine 7 theta minus cosine 3 theta, which is what this is, equals negative 2 sine 5 theta, sine 2 theta. Done. Now this one you can do a lot faster. I'll wait for you guys to catch up. I was about to go into something, but okay. What I was about to say is this. You can use a formula for going from a sum to a product a lot faster than from a product to a sum. Chavez, how? All you got to do is this part. You do this part where you figure out what A and B are. And now look, so just listen, don't write anything down, just listen. So what did I have? I had this right here. This is what you had. Where the A plus B, that was 7 theta, and the A minus B, that was 3 theta. See? And you told me that A was 5 theta, don't write anything down, just listen, and that B was 2 theta. As soon as you told me that, you can just replace the A right here, 5 theta, and the B right here, 2 theta. And look, -2 sine 5 theta, sine 2 theta. -2 sine 5 theta, sine 2 theta. You can go from a sum to a product faster, but going from a product to a sum, it's going to take some time because you have to figure out, you have to get rid of the halves and all that good stuff. Does that make sense, guys? Okay, awesome. I'm glad you guys are happy. Let's keep, well, yeah, ask, please. What's up?
Why is B 2 theta?
Oh, I made a system of equations, and I said that I know that A plus B has to, must be 7 theta. It must be 7 theta. That's from the big one here, the 7 theta here. And then I know that the smaller number is always the A minus. So I said A minus B must be 3 theta, must. It cannot be anything else. So then I just added, when I added, the B's cancel out, and you get 2A equals 10. So if 2A equals 10 theta, that means A equals 5 theta. And then once I know that, I can plug it into whichever equation I want. I'm going to call it equation 1 and equation 2. 5 theta plus B must give you 7 theta. So subtracting that, B gives you 2 theta. And then, of course, you can also check it with equation number 2. Equation 2, 5 theta minus B equals 3 theta. If you were to go minus 5 theta here, minus 5 theta here, negative B equals -2 theta, which means B equals 2 theta. Did I answer your question, Cruz?
Yes, thank you.
Okay. All right, guys, let's keep going. So now it says transform this product. So now that I have numbers, maybe it's easier to go, well, it doesn't matter. We're not gonna use the formulas. If you guys wanna use the formulas, go ahead. Transform this into a sum or difference. You notice it says cosine sine. So what would I do? Immediately in my head, I'm thinking, oh, it has to be a composite argument for sine. That 73 has to be the A, that 62 has to be the B. If you see the number 2, they're already giving you the A and the B, guys. So put that in there for your notes. If you see the number 2 in the front, they already give you the A, they're giving you the A and the B. If you see the number 2 in the front, they're giving you the A and the B. It sounds like they're throwing backwards at you, right? I'm giving you the A, like, okay. Maybe once you guys start driving, you guys will know what I mean. There's a lot of people that have road rage. Not me. I'm always the nice one, but there's scary people out there. Anyways, let's continue with this here. Here we go. I'm going to write sine, and I'm going to write 73 plus 62. The reason I wrote sine and not cosine, because sine is the only one that toggles. Look, cosine sine. Do you guys see that or no? Sine is the only one that toggles, guys. Chavez, what do you mean by toggles? It's the only one that goes sine, cosine, cosine, sine. And cosine does not toggle. Cosine goes cosine, cosine, sine, sine. So here we go. I'm going to write sine 73 degrees, cosine 62 degrees. There's my toggle. I put a plus because it has the same addition symbol. Cosine 73 degrees, sine 62 degrees. That's what I want right there. I want 2 of those. So I'm going to write the other one, sine 73 degrees minus 62 degrees. And I'm going to expand this. Sine 73 cosine 62 minus cosine 73 sine 62. If you don't put the degree symbol, that's fine here, but make sure you put it eventually. So catch up to there, guys. All those, how are we feeling? We feeling all right? Okay, check this out. You're gonna like this, or at least I hope. I hope you like this. there's only one way to get 2 of the cosine 73 sine 62. There's only one way. Right now, if I add them, the cosine 73 sine 62 is going to cancel out. So can I add these? No, you're right. I saw some of you nodding. Wait, nodding. No, this is shake. I saw some of you shaking your head. I just learned that. It's hard for me to tell the difference between nodding and shaking. So, well, for the head at least. Anyways, so I cannot add these. So that means I have to subtract. Does that make sense, Miss Riley, or no? Why am I subtracting? Okay. I'm subtracting because I want to cancel the sine cosines, but I want to add up the cosine sines. If I subtract, that minus turns to a positive. Right, guys? Okay. So here we go. So now that means that this on the left-hand side really turns to this. It turns to sine 73 plus 62 minus sine 73 minus 62. And this on the right-hand side just goes to 2 cosine 73 sine 62, which is what I already had anyways. That's what I wanted. And look, we did it without formulas. So we did it without formulas, guys. So now I see what this is. Let's see if I can add them up. 73 plus 62. That is 135. And then 73 minus 62, 62, 72, 73. That is 11. And there it is, guys. That is it. Are we feeling okay, guys? Here we go, guys. So when you become an engineer or a scientist, it has something like this. It says cosine 5 theta plus cosine 3 theta equals 0. And they want all the answers between 0 and 360. Now, I know you can just plug it into a calculator and find where they intersect. We can plug this into y1 or just see where it crosses the x-axis. And yeah, that is 1. But how do you do it algebraically? And it says hint, transform sum into a product. So if I do that, I should be able to figure out the thetas algebraically. So this bigger one is a plus b, and this smaller one is a minus b. And here on the side, I'm going to go a plus b equals 5 theta, and then a minus b equals 3 theta. That's a theta there. And then I'm going to add them. They're both 2 equations. The b's cancel out because they're opposite signs. 2a equals 5 plus 3, 5, 6, 7, 8. That's 8 theta. And I know how to divide. 8 theta divided by 2 is 4 theta. So now once you know that, you can calculate the b pretty simple. The b has to be theta because 4 plus 1 has to equal 5. And then 4 minus 1 has to equal 3. Does that make sense, Ms. Cruz, or no? Okay, perfect. So now that I know that, guys, here's what I do. I just set it up. I go cosine. Here's my 5 theta, the 4 theta plus theta. And I'm just going to expand. I expand it. Cosine 4 theta, cosine theta, minus sine 4 theta, sine theta. I go right below it, and I'm going to write the other one. 4 theta minus theta. That's your 3 theta. And I just expand it. Cosine 4 theta, cosine theta, plus sine 4 theta, sine theta. I write a line, and then I just say, Chavez, what am I doing? I am adding. Why am I adding? Because there's a plus symbol. So put the plus symbol here. That means everything stays as is. These signs cancel out. And here's my product. You're going to have 2 of the cosine 4 theta, cosine theta. So cosine 5 theta plus cosine 3 theta is equal to that. So catch up. Catch up. We're almost done, guys. This is the last one. If you ever have a math entrance exam without a calculator for like A&M College Station, I think they would probably give you a little easier number than the 4 theta there. But let's go ahead and figure this out. These are equivalent expressions. So I can now write 2 cosine 4 theta, cosine theta equals 0. I can figure it out real quick. You're going to have 2 expressions. Look, I'm underlining the cosine theta in red. If cosine theta is 0, anything times 0 is 0, guys. So where on the unit circle is cosine theta 0? At 90 degrees and at 270 degrees. I'm going to do the 4 theta in blue. This is a harder one, so I'll wait for you guys to catch up. All right. Where is cosine 4 theta equal to 0? Again, okay, I'm just going to go ahead and do this, guys. 4 theta equals plus minus arc cosine of 0 plus 360n. Not that I don't know where arc cosine is 0, but I have a 4 there, so I got to account for that. I know that cosine is 0 at 90 degrees, a positive 90 and a negative 90. Yes, I could say 270, but I don't want to use 2 equations. 4 theta equals plus minus 90 degrees plus 360n. I want to get theta by itself. I just divide by 4. Divide by 4, divide by 4, divide by 4. Let's see if we can do this without a calculator, guys. Theta, 90 divided by 4, well, let's see. 90 divided by 2 is 45. So 90 divided by 4 is like 45 divided by 2. 22.5. Maybe we would have been faster with a calculator. I don't know. All right. Let's get all our answers. Here they are. Theta equals the first one. Oh, put a plus minus in the front of that. The first one, 22.5 degrees. The second one is 90 degrees. So let me color code them where they come from. This one's coming from blue. This one's coming from red. And then comma. The next one's going to come from the blue one. Negative 22.5 plus 90. So 90 minus 22, 987, 67. 67.5, comma. And then again from the blue, the 22 plus 90, 910,112 from the blue one, comma. And then 157.5, comma. I'm just adding 90, guys, to the 67. That's easy to do. Just add 100, subtract 10. And then add another 90. So 112, 202.5, comma. And then the 157 plus another 90. So that's what, 247? 247.5, comma. And then I guess technically the 271. So here comes the 270s. These are all my answers, comma. And then 202 plus 90, 292. Yeah, I have a lot of answers, guys, comma. And then the last one, 247, 2337. There it is. All those answers, guys. If you were to graph this graph, you would have all those intersections, all those x-intercepts. All right, we did it. Sorry, guys. Let's come back, or let me come back. You guys are already there.